Welcome back, Science 10. Today we'll look at the next part of your booklet in the CR1 section, molecular compounds. So a couple of notes here to make. Molecular compounds are atoms that are held together by what is referred to as covalent bonds. And these types of atoms that make up molecular compounds are the non-metal atoms only. So those ones that you find over on the right-hand side of the table. So if I skim back a little bit here to our periodic table that was way back here. So we're looking at these atoms here. So the ones to the right-hand side of the staircase and to the left of this noble gas green group. So the yellow ones here, these sets here as well. Those are referred to as the nonmetals as you labeled earlier. Okay. So if we skim back here now, just flip to the booklet here quickly, back to molecular compounds. So they're on the right-hand side of the table. So covalent bond. To look at what a covalent bond is, it's a bond that holds atoms together by what we like to refer to as electron sharing. So rather than one atom losing an electron, and another atom gaining electrons, one or more, and then they are held together by plus-minus attraction, these ones share. So for example, this is a hydrogen and a hydrogen, and they come close enough to each other so that both of their electrons are shared. You can think of it as two people holding onto a chocolate bar and sharing it. Similar idea here. Electrons are the chocolate bar, the people are the atoms, etc. So it's a little bit different. Electron sharing. Okay, and if you go down on this sheet, you'll see an example of chlorine. Chlorine has 7 valence electrons in its level. So it needs to, as we talked about before, either it's going to gain 1 or lose 7 to have a complete outer level. If it loses 7, then this level would be the outer level. However, that's not the case. It's easier to gain 1 electron. So they come close to each other and they share each other's one outer electron. Therefore, as you can see here, this chlorine for some time would have 8 if we include that shared one. 1, 2, 3, 4, 5, 6, 7, 8. And then the other chlorine atom would have 8 as well if we consider those to be shared electrons. Okay. Some special cases of atoms that bond with themselves, such as hydrogen and chlorine, they are referred to as the diatomic gases. Di meaning the prefix for 2 items. So molecules that consist of 2 atoms. So here is a list of all of them. As you see there on the right-hand side of the periodic table, so hydrogen is stable when it's hydrogen gas, etc., etc. There's 7 of them here in total, and a neat way of remembering what they are is to remember the word Hofbrinkel. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. All of those are in that list of 7. So if you remember the word Hofbrinkel, that'll give you an indication as to which elements combine with each other in a covalent bond to form a diatomic molecule. Some other examples. Methane gas, which is the common name for CH4, looks like that. So you have a carbon. A carbon has 4 electrons in its outer level, so it needs to have 4 more. So it gets it from 4 hydrogens. So of course, chlorine will be 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer level. Each hydrogen is stable because in that first level, remember, 2 electrons make it stable, so hydrogen gets 2 as well. So everyone's happy. Water, H2O, you can see how that sets up. An oxygen that has 6 in its outer level needs 2 more. So if it shares 1, it gets 1 with this hydrogen, and shares another one, it gets another one with this hydrogen. Ammonia, of course, that's used in fertilizer here, and H3, nitrogen sharing with 3 hydrogens. So we'll take a look now at formula writing and naming. Basically, I just illustrated the first 5 prefixes. So mono means 1, di means 2. If we need to, we'll go higher up to 10, but for now we'll just look at the first 5. So 1 is mono. Di, as I mentioned, diatomic means 2. Tri, just like a tricycle, is 3 wheels. That's 3. Tetra is 4. Penta is 5. Of course, you know a pentagon is 5-sided figure, so that's where that comes from. So all we do here is we just simply look at what we have. So nitrogen monoxide. A couple of things here to note, which I'm going to get you to write over on this right-hand side here. The first element, or actually we'll do this. Do not use the prefix, not momo, but mono with the first element. So that's one thing to note. We don't use mono, so you can see it's just simply nitrogen. There's no prefix in front of it. And another thing to note, the second element uses the, as you can see, "ide" ending, just like we did previously there. You'll notice that "ide," they all end in "ide," so we use that form there. So nitrogen monoxide. So nitrogen, of course, is N, oxide is O, and we're told here it's how many oxygens? Just one. So it's just simply NO. That's the formula for nitrogen monoxide. Continuing on, carbon, you can see here, the easier thing to do would just be to highlight, okay, which elements we're using. Nitrogen and oxide, carbon and chloride. So I'm going to have carbon and chloride, carbon and chloride. So if we look here, there's just one carbon. Chloride uses the prefix tetra, so that's 4. So we need to indicate that we have 4 chlorides there. So we need to write a subscript 4 after that. So carbon tetrachloride is CCl4. Easy, way easier. You don't have to worry about balancing charges or anything. Vice versa. Of course, we know this is water, but if we were to name it using the IUPAC naming system that we just suggested, we of course see that there's hydrogen and oxygen, oxy-O, but instead of naming oxygen, remember this rule up here, the second element uses the "ide" ending, so it's not oxygen, it's oxide. And we have one oxygen on the end, so we have to use the prefix mono. Now, 2 O's beside each other, that doesn't look right. So quite often what happens is that one of those is dropped, so monoxide. And we do have more than one hydrogen in front. We have 2, and of course the prefix for 2 is di. So Di. So dihydrogen monoxide is the IUPAC name of naming water. If you go on the web, you'll see web pages telling you about the fears of too much dihydrogen monoxide, and really what they're talking about is water. So it's kind of funny. The last one here, you can see we have carbon and oxygen. So carbon and oxygen, but once again it has to be oxide because it ends in "ide." We have one carbon. So ideally we would put monocarbon, but once again we don't use the prefix mono with the first element. We use other prefixes though if there's more than one, but we don't bother if it's just one. And as we can see here we have 2 oxygens, so we have to use that prefix di there. So carbon dioxide. Okay, so relatively easy molecular compounds. So over on the next sheet here, you should be able to name these ones. Quickly going through here, water, of course we just did, so you should have no problem with that. Ammonia, if we go back and name some of these ones that had common names. Now, for example, methane, CH4. We of course know now that that is carbon. And I didn't mention hydrogen, but if hydrogen with the "ide" ending is actually not hydrogen or hydroid, it's hydride. Carbon hydride, and of course there's 4 hydrogens there, so I'd have to put, oops, wrong place, tetrahydride. So carbon tetrahydride is the name for methane. Water, of course, we just did. Dihydrogen monoxide. And ammonia, nitrogen trihydride. So sometimes hydrogen is used as that second element. So you have to be aware of that, hydride. Okay? So I'll get you to do this last sheet here. I think, so we have some of the ones here, methane, ammonia, etc. Ozone, I'm going to give you that one because we really didn't discuss that one. So it's just O3. That's kind of a different case. It's an element by itself. Over here we should be okay. Arsenic, you should be able to find that. That's AS. And the rest of these, and once again here, look at O3 we have. That's simply ozone. Okay. And then some of these other ones we have that we talked about before, the diatomic gases such as fluorine. It kind of does it. It's off by itself. It's one of those Hofbrinkel elements. I think there's another one here. Yes, here it is here. Iodine. Just simply iodine. And over here we have hydrogen. So there's that one as well. And I think the rest of them are pretty clear cut. You should be able to do the rest of those there. So we can go ahead and get started with that. See you next time.